In this segment, we're going to take a look at solving radical equations. So first off, what is a radical equation? It's just simply an equation that has a variable underneath a radical symbol. That may be a square root, maybe a cube root, maybe whatever. Our strategy in solving these is going to be, number one, isolate the radical. Make sure that it's the only thing on the side. There's no plus or minus, no multiplier with it. And then we're going to raise both sides to a power that undoes the root. So if it's a square root, we're going to square. If it's a cube root, we're going to cube. Now we do have one note of caution here when we're solving these. We can do everything right, get answers, but they really don't work. If I have even roots, then I have to check my solutions for extraneous solutions. And the only way that I'm going to determine that it's not really a solution is by working it all the way out. So we'll take a look at that. Okay, so solve the following. I've got the square root of this 3x minus 1. I have a plus 2 equals 7. Well, first off, I isolate. I have to subtract the 2, get rid of that, move it to the other side. So I get a 5 over there, and now I have this radical by itself. Since this is a square root, that means I need to square both sides. Squaring undoes or cancels that radical symbol, so we're left just with what's underneath, the 3x minus 1. On the right-hand side, we square as normal and get a 25. Then it's just a matter of simply solving the linear equations by adding the 1 and the dividing, and we get 26 over 3. Now, I'm going to go ahead and check this. So I'm going to take my 26 over 3 and I'm going to put it in for my x up here. The 3's cancel, that leaves me with 26 minus 1. Well, that's going to be the square root of 25. The square root of 25 is 5. 5 plus 2 is 7. So it does work. Okay, so what about this one over here? Well, the radical, this time which is a cube root, is already isolated. I don't need to do anything there. And because it is a cube root, we're not going to square, we're going to actually cube both sides, which means multiply something times itself 3 times. Here the exponent of 3 cancels the root of 3, and we get the 5x minus 2, and negative 3 times negative 3 times negative 3, that's what it means to cube, it's going to be a negative 27. So 5x equals negative 25 because we added the 2 to both sides. Divide and get x equals negative 5. Now on this one, I could check it with my calculator. So if I turn it on, it is. Let me clear this out. If I have the cube root, now you can find that under the math, and then you scroll down here, number 4 is cube root. Cube root of 5 times negative 5, okay, minus 2, close that up. Yes, that's negative 3. So if you don't want to check it by pencil and paper, then at least check it in your calculator. Let's try one more, and this one's going to be a little bit more involved. If I had the square root of x plus 7 equals to an x plus 1, what would I do there? Well, it's isolated. There's nothing over here with this radical, so we're just going to go ahead and undo it by doing the power on this one. We're going to have to square because it's a square root. But if I do that to the left, I have to do it over here on the right. When I have a quantity with a plus or minus there being squared, I can't just square these two things. That really means x plus 1 times x plus 1. So if I don't remember a special formula for filling something out like this, I actually have to do first, outer, inner, last, combine my like terms, and you should end up with x squared plus 2x plus 1. Again, we have a quadratic here, so that means I'm going to get everything to one side equal to 0 and try to solve from there. So I get x squared plus x minus 6. My first thing is always to try to factor it. If it wouldn't factor, I'd use a quadratic formula. Fortunately, it factors. So I get x plus 3, x minus 2. Setting each of those equal to 0, we get a negative 3 and a 2. Now why did I cross out the negative 3? Because I'm going to check my answer up here. So if I put negative 3 into this original problem for those x's, it would look like this, right? Well, the square root of negative 3 plus 7 is the same as the square root of 4, and a negative 3 plus a 2 is a negative 2. Now see, there's no negative over here on this left-hand side, so that's really telling me I want just 2 is my answer, and that's not equal to negative 2, so it doesn't work. On this one, when I plug the 2 in for both of the x's, it actually does work, so it's a legitimate solution. Now if you go ahead and you check the Blackboard notes, you will see some more examples worked out for your reference.